Math is natural. One of the most unique characteristics of man is his ability to imagine and contemplate things that are abstract, which are things that we can't see or experience with our senses. And one of the most difficult of all abstract ideas is the concept of numbers. Over time, man has learned to take this concept to a higher level, as he's learned to manipulate these numbers in what we call mathematics. Starting with the simple concept of adding and subtracting, man learned the shortcuts of multiplication and division. Then came the more difficult concept of equating one set of numbers to another set, which then led to the development of algebra, geometry, trigonometry, and calculus. Today, there are 26 different variations of mathematics. As scientists have explored our environment, including such sciences as geology, biology, meteorology, astronomy, as well as many others, they've discovered that they were able to convert the laws of nature into mathematical formulas. And as they did, what they further discovered is that all of nature seems to have built within it a complex mathematical blueprint that it follows. Scientists know that inside the cell of every living organism is a blueprint known as DNA, which is what the cell uses to know how to function, to build, repair, and duplicate itself. But what science is also coming to realize is that embedded in each DNA is an array of very complex mathematical formulas that determines what the overall structure of the living organism will look like and how it will behave. To illustrate this, when we purchase a computer, it comes with various kinds of programs that have mathematical formulas already built into it. And it's when the user puts certain information into the computer that the program then is able to perform the task that the user wants it to. Take, for example, when using a digital spreadsheet. The user inputs a series of numbers, and then the built-in program automatically adds all those numbers together and gives the answer that the user was wanting. This is what meteorologists do, because the computer they use to predict the weather already has built into it a series of very complex equations. And so, all the meteorologist has to do is put in the necessary information, and the built-in formulas automatically calculate what the weather will be like in the future. In the same way, if there is a mathematical equation already programmed into the DNA of every plant and animal, then whatever variations already exist in the DNA of that particular organism will be used by the pre-programmed formula to determine what the end result will be. Since there are many different variables in the DNA that can be put into that mathematical formula, this then results in a wide variety of different outcomes. One of the more intricate things that has been discovered in nature is something called fractals. These are made from a pattern that keeps repeating itself at different scales. Fractals were discovered by a mathematician named Benoit Mandelbrot, who developed a formula to be able to explain how fractals work. This formula works equally as well with patterns as it does with numbers. And as we look at nature, what appears to be something chaotic is actually a complex series of repeating patterns that follows Mandelbrot's formula. We see this all throughout nature. We see it in the shape of snowflakes, in spider webs, tree structures, and in the veins of leaves. We see it in the structure of lungs, blood vessels, nerves, kidneys, and other organs of the body. But more than this, we've come to see that the entire universe is inherently mathematical, as Einstein discovered when he developed his famous formula E=mc². The question scientists have debated is whether all this math we see in nature is just an invention of man, or whether man has discovered the math that already exists in nature. Stated differently, is it man's inventive mind that has created a way to turn anything into a mathematical formula? Or does nature truly operate according to the rules of mathematics? All of nature can be seen as patterns, and all patterns can be stated in mathematical terms. For example, light is made of photons that travel through space in the form of a wave pattern, and there are different kinds of waves. Depending on the distance between them, will determine whether it is a radio wave, a microwave, an infrared wave, visible light, ultraviolet, X-ray, or gamma ray wave. Sound likewise travels in a wave pattern, and because of this, we can measure the distance between the waves as well as the distance between the crest and the trough of a wave. We can also measure the speed of a wave. Therefore, anything that can be measured is something that can be expressed using mathematics. Alan Turing was a brilliant mathematician who was able to mathematically decipher the Germans' famous World War II Enigma code that was thought to be impossible to crack. In 1952, he published an article called The Chemical Basis of Morphogenesis, in which he proposed that the diversity we see all throughout nature can be explained mathematically. As scientists have taken Turing's formula and applied it to the many different forms of living organisms, from cell division to the spiral arrangements of petals on a flower, or the tentacles of a hydra, or the spots on a leopard and the stripes on a zebra, and even the waves of a sand dune, what they found is that his formula has proven to be very effective in explaining all of these many and varied patterns. Although there are still some who want to say that all of these mathematical formulas used to explain nature are nothing more than the inventions of man, yet the vast majority of scientists and some of the greatest minds in mathematics are convinced that nature operates according to the rules of mathematics, and that man is merely discovering what those rules are. When we talk about the laws of nature, the word law, by its very definition, is something that cannot change. For example, the law of gravity works the same everywhere throughout the universe. Light always travels at 186,000 miles per second. That never changes. And because natural law is constant, then it can be expressed in terms of a mathematical formula. What this tells us is that nature does not operate on the basis of random, arbitrary, and unpredictable changes. In other words, what looks like chaos, turmoil, and disarray to the untrained and unsophisticated eye actually has order and purpose to it. If that is true, then this is clear evidence that what we see in nature operates according to complex mathematical laws. When we see mathematical precision all throughout nature, the only explanation is that someone who is extremely intelligent deliberately designed all of nature to operate the way that it does. Man didn't invent math. He has merely discovered something that has existed from the beginning, which is why math is natural.